All right, so our first example that we have today is a truss system. But let me ask you before I start doing structure analysis for this truss. It's so dark, right? Do we need more lights in the back? The thing is, I tried. Can you try? Because I tried and it's all light, but let's. No. That's okay, right?
That's better.
Okay, all right. Because I don't want you guys to get asleep. Yeah. Okay, so this is the first application that we have, trust, but let me, before I do analysis for this trust, is that determinate or indeterminate? Determinate, right? I have externally, I have roller and I have hinge, it's sweet reaction, so externally it's determined. Internally, that's how actually the determinant trust look like. But if you found another member going that way and they are crossing each other, so that means there's more extra members that this trust doesn't need, right? All right, so I want to solve this structure using SAP 2000. So what we do actually in any structure analysis software, I'm sure that you guys all dealt with the structure analysis software. You all know it's garbage in, garbage out. It's input, output. If your input is good, your output is gonna be good. If you modeled everything right, the output is gonna be right. That's for any analysis software, including structure analysis, water, anything that has bad input is gonna be bad output. So what are we care about, or what is the most important thing when it comes to structure analysis? We care about many things. You need to model verbs. What we do some definition. We need to define everything in our problem. We need to define the members cross sections. We need to define the members material. We need to define the boundary conditions. You need to define everything. Because if you are doing a structure analysis and your material is a steel and you did it as concrete, that's totally not right. Well, it depends. Like if this is determinate structure, it's not gonna matter. But if it's indeterminate, it's gonna matter. Okay, all right. But let's model everything right. Let's not focus on determinate or indeterminate. Let's model everything. If this is a steel, I need to make it a steel. If it's concrete, it's aluminum, I need to make it right. Okay, that's the material. Cross sections is also a big thing. If this cross section is a beam 50 centimeter by 50 centimeter, you need to define a cross section that is 50 centimeter by 50 centimeter. If it's a steel section, I beam that has the flange width, I don't know, like 50 millimeter, and the height is like 100 millimeter. So you do it as what is in your problem, okay? So the definition is very, very important part of modeling in any software. The second thing, once you define everything that you have, you need to draw the geometry line. Like you need to draw all the members as it's supposed to be, or as it was in your homework, or as it was in your project. So you have to draw everything. You can't miss a beam, you can't mess with the geometry because it's gonna give you completely different solution. Okay. All right. The last part that I want to do is the loads. Like you need to look at what kind of loads do you have and how to apply this load at the exact location with the exact time. If you have a live load, you need to put it as a live load. If you have a dead load, you have to put it as a dead load. And also you need to understand that this software is automatically, like SAP 2000 can calculate the dead weight for a problem. Like for example, most of the structure analysis problems that I give you in the exam, or actually if you dealt with them in the basic structure analysis work, you don't deal with onward. Like we always give you a beam that has a bunch of loads. But I didn't tell you that this beam is a concrete and can calculate the own weight of the concrete. We always give you the beam with a distributed load. Okay. So if you draw this truss on a software and you put a bunch of loads, and I didn't tell you like in the header of the problem to include the own weight, you can't include the own weight of this truss because usually when we do analysis for trusses, we neglect the own weight with respect to the external loads that are on the truss. Okay, sometimes we do this if the own weight is small, but if the own weight is big, we calculate the own weight and distribute it on the joints, and we give it as a point on the joint. So it depends on what is the problem that I give to you. If I told you consider the own weight, you have to consider the own weight. Because if you consider the own weight in the structure analysis of trusses and all the trusses that you have solved, these trusses are going to be like beams. They are going to have a bending. So you have to draw bending on the truss. but we know that the trusses doesn't take bending moment, right? Because the own weight of the truss structure is a small with respect to this weight. Like for example, if this truss is a steel structure, and you have 5.5 ton, that's like 5,500 kilograms, and you have the own weight of this whole steel truss structure is like, I don't know, like let's say 500 kilograms. That's like nothing if you sum all these loads. Like if you sum all these loads, it's like almost 1,500 ton, and you have 0.5 ton of the only structure is only, that's a very, very small amount. That's less than even 5% of the total structural load. And you can actually include them in the joint load. But that's why we neglect the own weight of the truss members, because they are very light member, unless it told you to include them. Because if you include them, it's not gonna be truss anymore. It's gonna be, all these members are gonna have bending moments, okay? And we know that truss is only normal forces, tension, compression, right? They don't have bending moment. Well, in real life, they have. Like if you build a truss system, all these members are gonna have, but what is the value of this bending moment? The bending moment is very, very small, that can't be neglected. So that's actually, we talked about this before, how, when to neglect and when to don't neglect. So that's some few things that we need to talk about before starting structure analysis on any software. All right. So once you define all these, define the member cross section, define the materials, define the boundary condition, define the loads, draw the geometry, and apply the loads on draw the geometry, and then run the analysis. That's all what structure analysis software doing. Even if we are doing analysis for a building, we draw the columns, we draw the beams, we draw the slabs, we replicate the stories, and we make the building, draw the geometry, apply the load, run the analysis. Or what we have to do, you have to make sure that you have like your information that you put inside the software is good. Like for example, this load direction needs to be in the positive X. If you did it in the negative X, your problem is not right. If we putting a load on a slab system, the load needs to be in the gravity direction. If you put it in the Z direction, that means the load is gonna go up. So the slab, rather than bending down, is gonna be bending up, and the deflection is not gonna be. So that's, I have been teaching construction analysis softwares for like almost 10 years, and I saw many mistakes done by students in defining the loads, defining the cross sections, defining the load direction. So all these are typical mistakes when it comes to, it's basically in the inputs of the data. Some of them are mistakes that are like profound in your knowledge, like you don't understand things, and some of them like sometimes like you miss the units, like you go and apply the loads as a kilopounds, but the units are already defined as ton meter. So these things, but usually with practice, everything's gonna be good. Okay, so let's practice on this example. Here, like when you start SAP 2000, so let me maximize the screen. This is actually the interface of SAP 2000. The first thing that you start with is to, like any other software, you go to file and you start a new project, okay? So here, I'm gonna go file. I'm gonna say I wanna start a new model, but if you already have a project that you already developed and you wanna open it, you click on open. Okay, so let's hit new model and see what we're gonna have. So when you do a new model, there's different ways to start your model. You either start with a template that SAP 2000 already have, or you might be like, you can pick like a beam template or a 2D truss template or a 3D truss template, depends on your problem. To be honest, I can start with 2D truss, is gonna be very easy. And look at this, it's like almost the same to what we have. It's gonna ask you for many parameters. What is the spacing between the panels, or what is the height of the truss? So it's gonna be asking you for many information. Or you can build a grid system that is gonna help you to draw the truss very quick. Okay, or you can already have the truss already drawn on AutoCAD and import it right away. So I start with a blank page and I import the file that I have from AutoCAD to SAP 2000. Okay, so what I'm gonna do right now, I'm gonna start with grid. But before I start with grid, I need to make sure that the units, because once you hit the units, wrong, everything's gonna be wrong. Okay, so we need to check the units. The units are ton force meter, and I will go check on my truss and see what are the units there. So I will go back here to my AutoCAD file. I found that loads are ton and these units are in meter. So my units are good. But if it's not, if the problem that I gave to you has kips inch, so maybe you change it, like you try to find if there's something kips inch, so you put it, if it's kips feet, you are gonna put kips feet, okay? All right, so my units are good, and I'm gonna go to grids only. Okay, when you hit grids only, it's gonna ask you some information about the grids. I'm gonna build you some lines on the drawing area that is called grids, and this grids is gonna help you to draw your structure very fast. Okay, so let's look at the problem that we have and see what is the best way to do the grids. Okay. If I go here, usually truss systems like SAP 2000 is like, this is X direction, this is Y direction, and the up is the Z direction. This truss is in what plane? X is Z, right? So you have X and you have Z. If there's Y, if this is 3D, so Y is going inside the board. There's no Y direction, it's only 2D truss. Okay, so we know that it's in X and Z direction. So what is the number of grids that I need to have in the X direction so that I can draw this truss easily? Just think. Okay, if you look, you will say, oh, I have 4 spaces, so I'm gonna do 4 grids, but you need 1 at first and 1 at the end. So 1, 2, 3, 4, 5. Because if you build 4, you will end up here. So I need to have 5. How about Z direction? 2, right? How about Y direction? You can say 0 because there's a start, there's 1. Okay, this is Y, it's 1, and there's no more. Okay, all right, so let's do this. So I'm gonna say, okay, I have the spacing in the X direction is 3 meters, and in the Z direction is 4.4. So I will go here. It asks about the number of grid lines. We said at the X direction is 5, Y direction is 1, and Z direction is 2. The spacing in X direction is 3. Y direction, it doesn't matter if you put 100 because it's only 1, okay? Z direction is gonna be 4.4, and I don't have, oh yeah, here it asks you if you, all right, what happened? Okay, so here it asks you if you wanted to like move your truss from the 0, 0, 0, like if you want your truss to be drawn at 5, 5, 5, okay? If you wanna like to do it in the 5th floor, so you go Z 5 by 3 or something. But here I'm doing only the truss, so it's gonna be 0, 0, 0, and I'm gonna hit OK. All right, so right now, once I hit OK, it's gonna divide the screen into 2 screens. One of them 2D and one of them 3D. Actually, you can add more screens if you want to make this 4. You can click on add view and add another view, but usually I always go with 2. One is 2D and one is 3D. 2D, I use it to draw my models. 3D, I use to visualize my model. Okay, that's what I do actually in any analysis software. Either tabs, I do the same. I have the 3D and I have the 2D. All right, I have XY direction and it's only showing 1 line. And that's actually makes sense because if you look at the truss from the top, it's going to be 1 line. What is the view that I need to look at here so I can draw the truss? XZ, right? So if you go up there here, you will find what views that you want to show here. If you want to show the 3D, it's going to be like this, XY, XZ, and that's what I want. So XZ, that's what I want. I have the 5 or the 4 spacing and 1 spacing, and right now I will be able to draw my truss. Okay. All right, but before I draw the truss, I need to define the cross sections, right? I need to define a section that I can draw. You can actually start drawing before defining a section, but when you start doing this, the software is gonna develop like a template, like a cross section with any name, with any material, with like not the any material, like the one that already be predefined in the software. So what we want to do, you can do this, but if you did this, you have to do a extra step. You go define the section and reassign the section, change it. So why should I do that? I can define my sections first and then draw them, rather so I can skip this step. All right, so before I draw,
Like let's say that you're gonna draw, it's gonna be very easy. I can, if you go here, you will find something called draw a frame. So, or you can come here and you will find all the drawing tools that you want to do. Like I can draw a frame by like draw a frame or cable. When I click on it, this one or this one from any, so look at the section, F section 1, just any section. And then the line object is a straight frame. So they put any frame. I believe this frame is a steel. Like if we go check, we'll find it steel. But let's keep it that way. If I'm gonna draw a section, okay, I'm gonna draw my truss. I'm gonna pick this point, go to this point, and then this, and I can go here. I can draw it there, and I can draw all the truss that way. Actually, there's different way to draw the truss. There's something is called big quick draw frame. Like if I click on it, the one that has the red dot, once you click on a grid, oh my God, I forgot to off the power.